Hello friends, I Prof.Darshan Thakur from Terna Engineering College Dharashiv welcomes you on my YouTube channel for this subject head network theory. So friends, as far as this session is concerned, so we will try to learn another circuit analysis technique whose name is nothing but what? The nodal analysis. So as you can see, the objective for our today's session is to determine the current flowing through this 10 ohm of resistor by using the nodal analysis, right? So first of all, we need to understand the fundamental concept of this nodal analysis, or one question arises in our mind ki why this nodal analysis is being preferred over the mesh analysis or the loop analysis, right? Because as far as this existing network is concerned, we too can determine the current flowing through this 10 ohm resistor by using mesh analysis or by using loop analysis also, right? But by using this nodal analysis, the main advantage of this nodal analysis is to what? Is nothing but we do can minimize or we do can reduce the number of equations which are to be written for this existing network, right? Because from mesh analysis point of view or from loop analysis point of view, if we try to look around to this network, so at that time we are coming on to this conclusion ki there are 1, 2 and 3 identical loops or mesh we are having with us, right? So as we are having 3 loops or as we are having the 3 mesh, means what? We need to apply the Kirchhoff voltage law to each and every mesh to obtain the desired equation for loop number 1, loop number 2 and loop number 3. Means totally we are having 3 equations with us in case of that loop analysis. But the same network we do can analyze with the help of this nodal analysis, right? Now in case of this nodal analysis, just similar to this Kirchhoff voltage law, we are supposed to use the Kirchhoff current law in case of this nodal analysis, right? Now how this Kirchhoff current law is being used in case of this nodal analysis, laterly we will try to learn definitely how to apply the Kirchhoff current law. But as far as this nodal analysis is concerned, so first of all we need to understand the meaning which is coming out of from this term, that is nothing but our node, right? So from electrical network point of view, the point at which multiple number of branches are interconnected to each other, that point is nothing but what? We do can call it as a node, or we do can call it as a junction at which multiple number of branches are interconnected with each other. So first of all, what we need to do in case of this nodal analysis, the first important step is to determine the number of nodes which are present into that existing network, right? So from sake of observation, first of all what we need to do, we need to observe ki how many number of nodes we are having with us into that existing network. Then and then only we do can apply or we do can adopt the Kirchhoff current law strategy, because according to the Kirchhoff current law strategy or according to this KCL, basically this KCL deals with incoming and outgoing current. So we are supposed to apply this Kirchhoff current law to that particular node. So according to this Kirchhoff current law or this statement of that Kirchhoff current law says that summation of all incoming and outgoing currents to that particular node equated to 0, or summation of incoming currents equals to summation of outgoing currents. This is a very simple statement of this Kirchhoff current law. So what we need to do here, we need to apply the Kirchhoff current law to each and every node once total number of nodes are being detected from this existing network. So this is the way by which we do can analyze the circuit by using this nodal analysis technique, right? So as I told you earlier, node is nothing but what? The point at which multiple number of branches are to be interconnected with each other, right? So this is how our circuit will look like. In this circuitry we used to have some resistive element, as well as we are having two different types of energy sources basically, right? As I told you earlier, energy sources means either we can have the voltage source or current source, right? But in this existing network we are having one voltage source of 20 volt and we are having one current source of 4 ampere. Again another question arises in our mind ki there are two different types of energy sources we used to have generally in case of this AC and DC network. These two energy sources are nothing but what? The dependent energy sources and independent energy sources. Now basically as far as this network is concerned, so these two energy sources belongs to the type of independent energy sources, right? Means they are not depending on any particular element or any particular current or voltage which is present into that network, right? Probably in next session we will try to learn how to analyze this network which consists of dependent energy sources, means dependent voltage source or current source. So dependent source is what? Whose value depends upon the existing value of voltage or current which is present into that circuitry. Now for sake of moment we need to understand that these two are the independent energy sources. One is voltage source and another is nothing but what? Current source. Apart from these two energy sources, we are having 1, 2, 3 and 4 different resistors. All values of resistors are lying in terms of few ohm, like this is 5 ohm resistor, 10 ohm, 10 ohm and 20 ohm. So our area of interest is to determine the desired current flowing through this 10 ohm of resistor by using this nodal analysis technique, right? So in that first step we need to observe ki how many number of nodes we are having into that existing network, right? So as I told you earlier, node is nothing but what? The point at which multiple number of branches are interconnected with each other, right? For sake of moment, as you can see, this will be the first branch, second, third and fourth, right? The lower terminal of these 4 branches are interconnected to this point. So that point itself is call it is as a one dummy node or the ground node, because we don't have any subsequent elements which is present in between the lower ends of these all branches. So obviously this will be the ground node. We can call it as GN stands for what? The dummy node or the ground node. Similar to this ground node, we need to define the another existing nodes which is present into that existing network, right? So from sake of observation, as you can see, the node is nothing but what? The point at which multiple number of branches are interconnected to each other. So this particular point can be called as a first node. Similar to that, this point can be called as a node number 2. Means totally how many nodes we are having? One more time I will repeat. Node is nothing but what? The point at which multiple number of branches are interconnected with each other. So at this particular node, how many branches are interconnected to each other? This will be the first branch which consists of this 5 ohm of resistor along with this 20 volt of battery. Second branch consists of this 10 ohm of resistor. Third branch again which consists of this 10 ohm of resistor, right? How this vertical 10 ohm branch is connected into that circuitry? The upper end of this branch is kept at this node potential and the lower end of this 10 ohm of resistor is being kept at that ground node. Same things happen in case of first branch. The upper end of this first branch which consists of this resistor and 20 volt battery is connected to the first node potential and its lower end is connected to the ground node, right? But the unique identity of this branch is nothing but what? It is lying in between these two node potentials. Means after that what we need to do? We need to assign a certain potentials to this node. So for sake of our convenience, we can call it as a VA and this will be VB. So VA and VB, these are the two node potentials belongs to node number A and node number B. Coming back to this Kirchhoff current law, now it's time to apply the Kirchhoff current law at this particular node. So one by one, initially that Kirchhoff current law is being applied at this node potential VA. After that, Kirchhoff current law is being applied at node potential B, VB, right? Means totally we are having how many equations? Simply we are having only 2 equations. By the virtue of these 2 equations, we can determine the desired current flowing through this 10 ohm of resistor, which was not possible in case of this mesh analysis or in case of this loop analysis. In case of this mesh or loop analysis, what we need to do? We need to apply the Kirchhoff voltage law to each and every close conducting path. Means we need to declare the 3 equations and with the help of that scientific calculator, we need to solve these 3 equations. So in order to reduce the number of iterative equations, this nodal analysis is being preferred over the mesh analysis or loop analysis that we need to understand. Now, Once we know that there are two nodes, their potentials are nothing but what VA and VB. Now it's time to apply this Kirchhoff current law. According to this Kirchhoff current law, the algebraic sum of incoming currents plus outgoing currents equals to 0, or the summation of incoming currents equals to the summation of outgoing current. This is the simple statement of this Kirchhoff current law. So carefully we need to look around at that node potential VA. So at this node, how many branches are connected? 1, 2 and 3. So accordingly we need to assign the branch currents for branch number 1, branch number 2 and branch number 3. Means this will be I1, I2 and I3. Right. So from this node analysis point of view, similar to that mesh analysis, we had assumed the direction of fundamental branch currents ki either clockwise or anti-clockwise, right? So similarly here what we need to assume here, the direction of these three branch currents, whether these are incoming towards this node potential or outgoing from that node potential, right? It is not mandatory to consider each time all the branch currents can be incoming or all the branch currents can be, it's up to we people ki according to our own convenience we do can assume. So if suppose this will be the first branch current, that can be, call it as a I1. Here I will write. Again this current is outgoing from this node. Again this current will be I2 and this current will be I3. So here we need to assign the names of this current I1, I2 and I3, because these three branches are interconnected at this node potential VA. So when we apply KCL at node A, so according to this Kirchhoff current law, summation of incoming currents plus outgoing currents equals to 0, right? Or sum of incoming currents equals to outgoing current. Now we are having three branch currents and their directions are assumed as a outgoing from this node. None of the current is being assumed as a incoming, right? So we need to write the current equation for each and every branch. So according to that Ohm's law, I equals to what? V by R, right? So when we apply this KCL at node A, so the KCL equation will become what? This is the first outgoing current I1, this is the second outgoing current I2 and this is the third outgoing current I3. I1 plus I2 plus I3 equals to 0. This is how that KCL equation is to be written. Then after that we need to define the actual value of this I1 is nothing but what? Current flowing through this 5 ohm of resistor, right? How this branch is connected? See, this is node potential VA, this is 5 ohm of resistor, this is the battery of how many volt? 20 volt, and this is the ground node, right? And how that direction of current is to be assumed? Outgoing. So I equals to what? According to that Ohm's law, V by R, right? But in this subsequent branch we used to have this 20 volt of battery, right? So how to consider this I1 is considered as outgoing from this node. So this potential VA, how to map this 20 volt of battery? As we are going from positive plate to the negative plate, this is a positive plate, negative plate. So opposite sign we need to consider negative, minus 20 divided by the overall value of resistance is how much? 5. So this is how that I1 is to be written, VA minus 20 divided by 5. What about I2? I2 is nothing but what? Current flowing through this 10 ohm of resistor. How it is being connected? This is VA, this is how many ohm of resistor? 10 ohm of resistor, and this is ground node, right? And I2, right? This is nothing but what? I2. So I equals to what? V by R, right? Here the upper end of this branch is kept at VA and lower end of this branch is kept at ground node. So it will become V by R. So plus VA divided by 10. This is how that I2 is to be written, right? I3 is nothing but what? The current flowing through this 10 ohm of resistor, which is connected in between VA and VB. How it is being considered? Outgoing from this node VA, right? So at that time the potential of VA is greater than VB. When we are supposed to apply the KCL at node potential A, or that first node whose potential is nothing but what? VA. So accordingly again Ohm's law, I equals to V by R, but which V? Because this resistor is interconnected in between these two potentials. So we need to subtract these two potentials from each other. VA minus VB divided by the value of resistor is how much? 10. So equals to 0. This is how that equation is to be written, right? Then after that, simply we need to perform simple mathematical simplification or manipulation. So the term that can be divided with 5 and 10, so LCM can be considered as a 10, right? So it will become 2 times of VA minus 40 plus 10 will get cancelled, VA plus again here VA minus VB equals to 0. So this is how that equation will look like. Then see, the equation will become what here? This, how many VA terms we used to have? These 2, 4 VA minus VB, and this minus 40 is being shifted to this left hand side. Again this 10 is being multiplied with 0, so again it will become 0. So it will become plus 40, right? So 4 VA minus VB equals to 40. This will be our equation number 1 when we apply the Kirchhoff current law to this first node whose potential is nothing but what? VA. So similarly, when we apply the Kirchhoff current law at this node number 2 whose potential is nothing but what? VB. So at that time also we will come to know how many branches are interconnected to each other at this particular node. So again 1, 2 and 3, right? So one more time, now the direction of current flowing through this 10 ohm of resistor can be considered as outgoing. The current flowing through this 20 ohm can be again considered as outgoing, and the current flowing through this branch can be considered as again that can be considered as outgoing. So this is I1, I2. So one more time, it is I3, it is outgoing now. This will be I4 and this will be I5. So these 3 branches are interconnected at this node potential VB. So again one more time we need to apply this Kirchhoff current law at this node number 2 whose potential is nothing but what? VB. So again according to this KCL, summation of incoming plus summation of outgoing currents equals to 0, or summation of incoming equals to summation of outgoing currents, right? So how many currents are there at this particular node? There are 3 identical currents, and the directions of these 3 currents can be considered as outgoing from this node, right? So there is no question about this incoming current. So the KCL equation, apply KCL at node number 2 whose potential is nothing but what? VB. So we are getting this type of current equation, I3 plus I4 plus I5 equals to 0, right? Now I3 is nothing but what? The current flowing through this 10 ohm of resistor. Now how it is connected? It is in between VA and VB. 10 ohm VA, VB, and it is considered as outgoing, means the significance of VB is greater than VA. So the current equation will become what here? VB minus VA divided by 10. How about I4? I4 is nothing but what? The current flowing through this 20 ohm of resistor. How it is connected? One end of this 20 ohm is kept at, or upper end is kept at VB, and lower end is kept at ground node whose value is nothing but what? 20. So I equals to V by R. So VB divided by 20. This will be the current equation for I4, VB upon 20. And another thing which we need to understand, key in this adjective arm, apart from this current source, we don't have any additional component which is connected or associated with this branch. We don't have any resistor, inductor or capacitor, right? Simply we are having only one independent current source whose value is nothing but what? 4 ampere. Means here we need to understand key the I5 is nothing but what here? The I5 is nothing but what? 4 ampere, and according to the direction of this current source, because what this arrow indicate? The direction of current. the tendency of this current or the original current direction is nothing but what? The incoming towards this node. But how the direction of current is to be assumed? It will be the direction of current is to be assumed as outgoing current, but actual manner, the original nature of that current is nothing but what? Incoming towards that node, right? So due to this opposite reaction, the desired value of this I5 will be what? That can be considered as a minus 4 equals to 0, right? You have no need to tabulate this I5 because I5 is nothing but what? The desired current produced by this current source of 4 ampere. Why this negative sign is being taken into account? Because originally the direction of this current is incoming towards that node, but while applying this Kirchhoff current law, the direction of current can be considered as outgoing, right? So due to this reverse engineering, this negative sign is being taken into account. So one more time, again we need to solve this equation. So the term which can be divided, it will be some, if suppose 20, LCM will be 20. So it will become 2VB minus 2VA plus VB minus 24 is 80 equals to 0, right? So this equation will become what? Minus 2VA plus this 2VB plus VB, 3VB. This minus 80 is being shifted to the right hand side of this assignment operator, so it will become plus 80, right? Meanwhile this 20 is being multiplied with this 0, so it will become 0. So this is your equation number 2. Already we are having equation number 1. 4 times of VA minus VB equals to 40. Equation number 2, minus 2VA plus 3VB equals to 80. Right. Then when we solve these two equations with the help of this scientific calculator, so at that time we will come to know कि VA equals to 20 volt and VB equals to 40 volt. In the last session of this video, I will share the procedure how to tabulate this V and VB with the help of this scientific calculator. So our area of interest is what? We are supposed to determine the current flowing through this 10 ohm of resistor. Means we need to determine this I2 fellow. So I2 equals to what here? I2 equals to V by R, VA upon this 10 ohm. VA equals to how much? 20 upon 10. So current flowing through this 10 ohm resistor, 10 to the 22 ampere, right? So such type of questions are being asked in your university question paper for at least 6 or 8 marks. So this is the procedure which we need to follow in case of this nodal analysis, by which we can minimize the number of equations which are to be required to analyze the desired AC or DC circuit. So I just hope you had understand all these things. Thank you. Okay friends, so as we are having these two identical equations with us, after applying the Kirchhoff current law to that existing network, then with the help of this scientific calculator, definitely we can solve these two equations. So for that purpose, first of all we need to go through this mode option. Then once that mode button is being pressed, then after that we need to press the key belongs to this equation. Once that equation mode is being entered, then as we know we are having two variables with us. So here such type of data we need to input. Now this A1 is nothing but what? We need to enter the coefficients of these two equations. So equation number 1 is 4 times of VA minus VB equals to 40. So the coefficient of VA is 4, means here A1 equals to 4. Then after that we need to enter the coefficient of VB, that is nothing but what? Equation number 1 minus 1. Then C1 is nothing but what? 40. Sorry, it is 40. Then we need to enter the coefficients of equation number 2. So the coefficient of VA is nothing but what? Minus of 2. So it will become minus 2. B2 is nothing but what? The coefficient of VB is 3. So that will be enter. C2 equals to 80. After entering the coefficients of equation number 1 and equation number 2, once we press this equality operator, then we are getting x equals to 20, means VA equals to 20 volt and y means VB equals to 40 volt. So in this way, with the help of this scientific calculator, we can solve these two unknown equations in order to determine VA as well as VB.